So our example for a quadratic algorithm will be looking at bubble sort. So hopefully you've seen it before, but if you haven't, bubble sort is fairly straightforward to do. I'll just call it sort. And what it's going to do is that it's going to take in a list of items, and it's going to sort them from the smallest to the biggest, right? And we've got this list E here. Now, unfortunately, I can't just sort any old thing, so I've got to do a bit of a segue for a bit, right? A list of E would mean it could sort. I could take in any E whatsoever, right? I could take in any type whatsoever, and then it would sort them. But not everything can be sorted, right? How do you sort a bunch of scanners? I could pass in a bunch of scanners. Or even better, just random objects, like literal object classes. How would you actually sort that? Or say it was a list of lists. How do you sort one list in comparison with another? Not everything can be sorted, but fortunately Java has a way to denote whether something can be sorted or not. And that's through the comparable interface. So I'm just going to pull that up by just typing it over here. Comparable, and I'll just say comparable over here, C. And I'm going to click on it just to give you pull up the interface, right? And so it takes in public interface comparable T, which takes in a type, and it simply has one method called the Compareto method. Now the Compareto method is actually fairly straightforward to use. All right? Compareto works fairly easily, fairly straightforward. Now, the reason we have Compareto is because you can't use the greater than sign or the less than sign, right, on everything, right? That only works for primitives or for numerical numbers, right? That doesn't work for everything. The Compareto works on anything that there's an order for, anything that you can say this thing goes before that. Not necessarily this is less than this or this is greater than this, but that's the case a lot of the times. But this comes before this or this comes after this, right? So how does it work? Well, it returns an integer. If Compareto, right, we've got the Compareto method, right? And I believe, how does that look? Capitalized. Compareto method, right? If Compareto returns a negative number, if it returns something less than 0, that means, right? So let's say we're doing a dot compare to b. If the result is less than 0, that means a comes before b. If the result is a number greater than 0, that means that a comes after b, or b comes before a, whatever your preference is. And if the result is equal to 0, as you may have well deduced, that means that a and b have the same, basically are the same rank, which essentially means that for the sake of the Compareto method, they're the same. All right? Now, any object that can be put in order implements this interface. So, for example, we can see this by using our integers. So I'm going to just comment out all this stuff here and use the integer class to do this. All right. So integer 5, sorry, integer x equals 5, integer y is equal to 1, a dot x dot compare to, right? See, it has that, and it takes in something of the same type. X compared to y, this will return, let's see what it returns. It returns 1, a positive number, right? Because x is greater than y, so it returns a positive number, right? That's what we had according to the quick sheet I just came up with, right? A comes after B. Right? 5 comes after 1. But this is useful because it's not, you don't necessarily have to return 1 or negative 1. System.the_print line bagel dot compare to Batman. Right? It returned -13, which is useful information for a string. So, and you might be able to figure out why it returns -13. But for the purposes of comparing the Compareto method and just learning it, oh, that's a negative number. Well, bagel comes before Batman. If we look at that, BAG does come before BAT. So we can use this to rank. So we can use the Compareto for strings to see which one comes first alphabetically, right? So, all right. End result is that what we can do over here to enforce, because I've been getting this question a lot with the second homework assignment, to enforce that everything is comparable, that everything can be sorted, we type in E extends comparable E. Okay, that looks scary, but what essentially this means is that when we put the extends here, this enforces that E is going to be a subclass of comparable. And the second E here is because the comparable does take in a generic. And essentially it's saying, okay, you're going to compare it to what? Well, I'm going to be comparing E. I'm going to take in any E where it's comparable to itself. That's what this translates to. We're not really going to see this again until we get into trees. But essentially, this is how I enforce that basically everything in the list is comparable. And watch, if I do list.get I, right? If I do like list.get1, if I type .compare2, it will show up. If that comparable wasn't there, it's not going to show up. Right? I remove that, and boom, it says, no, you can't do that. You can't ensure that everything there is comparable. This means that everything's comparable, which means it has the Compareto method. All right. So with that, I'll get on to bubble sort.